Okay, so let's illustrate the whole ecosystem that the motion card should fit in and why I think this makes perfect sense for makers. So originally I thought I would be targeting a product that actually encapsulates all of this, including stepper motor drivers, a PSU, and perhaps even hardware running the Linux CNC, which is the platform I'm focusing on. But then I realized, like, if it's for makers, then the only common denominator is actually the motion card, perhaps the hardware running Linux CNC, but the rest is completely dependent on what machine they are building, how powerful motors they need, therefore what stepper drivers they're going to choose, and even what voltage power supply they're going to use. So I realized, like, we need to focus on the motion card, and then I came up with this ecosystem, which is not essentially new. It's just that this product seems to be kind of non-existent on the market at this point in time. And so why I chose Linux CNC is because from what I have heard, it's almost as good as industrial systems while being open source, meaning you don't have to pay license fees for software as it is in other areas of CNC. And you can run it pretty much on anything. But what I mean by that, if you meet Linux CNC's requirements, you can surely run it. Mostly I'm targeting something like mini PCs with double Ethernet ports, or the Raspberry Pi compute module, which with its motherboard does have double NICs, so that one can be used for the LAN and the other can be used for the motion card. But if people want to go even cheaper, they might just have an old tower PC in their basement, or they can even buy them for real cheap. And so it's up to them. And all the other hardware is basically standard. It's all available online in different specs. I'm talking about stepper drivers, demotors, power supplies, whatever the machine is going to need. This can handle it all. And so what the Aphys Motion card does, it communicates via UDP essentially with Linux CNC, and it transmits the motion signals as well as signals for other inputs and outputs, such as for limit switches, for the spindle, and for other sensors, like if you've got a door sensor or something like that. And I also want to have I/O for encoders in case you are building a machine that where you care about it not getting out of sync. I haven't really seen this feature within any of the products in a similar category. So this is something I really would love to get onto this product. Now, why did I choose an FPGA architecture? That is kind of tied to the question why I completely avoided speaking about ESP32 based boards, which are quite regularly produced at this point in time. And so I'll explain just that. Actually, my current plasma plotter is equipped with a Corgi board, which is a ESP32 based board. And I found it to be kind of a good fit for the machine. And I really think the makers of this board did a great job in terms of what it can do, in terms of its documentation, and even quite nice pricing on it. However, there is the Ethernet feature that I'm missing, that pretty much all ESP32 boards kind of miss, because ESP32s natively only have no connectivity or Wi-Fi or Bluetooth, and of course they have USB and UART, but they'd have to be expanded with Ethernet, which is actually not as simple as it sounds, but it's kind of building upon an architecture that already has some limitations in terms of, I know for instance boards based on ESP32 can be operating a 6-axis machine. However, they don't have sufficient I/O for 6-axis to have limit switches, encoders, as well as other sensors. It just runs out of these, and I think it's already thanks to a few components that actually expand the ESP32's capability from what would normally seem as like 3 axes and a couple of I/O ports for that. It's a good job done there. However, it has its limits. Now, why am I even thinking about more than 3-axis machines is because even with a plasma plotter, I'm already using 4 axes, and I believe that with a mill or a similar machine, it doesn't have to be as big of a machine, and you can already reach the need for maybe 5 or 6 axes to be operated. So I really want the motion card to be able to do just that without having to worry about, do I have enough I/O for this? So that's basically why I don't want to go after ESP32s. Of course, it's a affordable platform. It's widely used, but it has limitations in I/O. It has also limitations in terms of the frequency, which could be potentially a problem for some spindles, etc. And it doesn't usually have Ethernets. I would also like to answer why I haven't been content with the card having Wi-Fi only, and that is because in its sense, I believe that we need reliable data transfer, and that leads towards Ethernet anyways. I'm a fan of having Wi-Fi coverage everywhere, but at the same time, I struggle with my current ESP32 board's Wi-Fi because it hasn't been able to connect to an AP, which I might just have a faulty board and it just refuses to do that, and all other boards are fine. But it's already prevented me from using the system in a way I wanted, which is have a device from which I load the G-code onto it, and at the same time I can be doing other workflows like researching the internet or even stuff like downloading files from my server. This requires me to kind of switch Wi-Fi's, which is really inconvenient. Another point is I need this product to work with all sorts of machines, some of which might produce high frequency EMI, such as the plasma plotter I have. Now, I know from the scientific standpoint that the frequency of Wi-Fi, which is 2.4 or 5 gigahertz usually, is different to what the plasma plotter actually emits on paper. But the reality is I have seen people complain about high frequency plasma plotters actually interrupting their Wi-Fi. So I do believe it's a valid concern, and I do believe you're definitely gonna do a good job with having a shielded Ethernet, take care of the communication, and that should just prevent any problems in this area. That is actually my drive, why I don't want to settle on Wi-Fi, and why I really believe this product should have Ethernet.